Good afternoon. Welcome to the Rutico webinar on SLC 500 modernisation. My name is Jackson Michaelis. I'm one of the automation software product sales specialists in the Southeast.
And I'm Steve Jackson, also automation and software specialist, but I cover the Northeast. Thanks for joining us this afternoon. Just a quick note, we've got a question and answer session on there. If you want to feed your questions in there, we've got a team in the back which will try and answer that. And we'll cover some of the Q&As at the end. Okay, so we've been speaking to people for what seems like a good few years now about the impending end of SLC 500. You can see on the slide here from 2021 that parts were moving towards end of life and discontinuation. Well, that time is now. I think the only part that you can buy now for SLC pretty much is the battery. After 30 years of selling massive worldwide sales, then the SLC has been moved on, and this is definitely the time to start looking at migrating your systems. So if we're going to move the SLC, then the perfect model is the Compact Logix 5380. You can see here we've got an SLC on Ethernet and another one on serial. That's a dead straightforward conversion through to the new hardware. We've got Ethernet on there. There's also a serial card where it'll support DF1, it'll support DH485 if you're still using that, and a couple of other protocols as well. If you've got systems that are still tied into DH+, which is quite common for SLCs, or maybe you've got stuff on the old remote IO, then in conjunction with the ProSoft, we've got solution gateways which can help maintain messaging through there, maintain the hardware until such time as you've got the whole system modernized, migrated, then you can move those gateways out of the way and everything will be communicating on Ethernet ideally. A couple of other options on there. You might want to leave the SLC IO in and just change the processor while you're getting everything converted and making sure that everything's okay, and a little bit of a comfort factor. So you can do that by swapping the SLC out for an Ethernet card and carrying on with the existing IO in most cases. Another option that some people plump for is to replace the SLC with control logics. Now that's a bit more of an expensive option, but the form factors are exactly the same, so all the spacing is going to be the same. That might help with your wiring, and some people are just happier with that kind of format. It doesn't matter, everything's going to work just the same anyway.
Steve touched on the Compact Logix 5380 as our preferred controller to migrate to. There's a number of reasons for choosing the 5380. It's a much newer quad-core processor. It's got dual gigabit Ethernet ports, which allow you to use a wide variety of topologies, including device-level ring. You've got 31 local I/O modules, and you've got the ability to program that with Studio 5000 Logix Designer. This is the same software that we use throughout our entire Logix range of processors. So whether you're going to Compact Logix or Control, a lot of the stuff that we're going to go through is relevant in this case. With it being a new and up-to-date controller, it's also capable of SIP security, and it's 6443 compliant, so you've got those covered as well. Got a quick video here, and it just goes over the mounting system, which is quite useful while transferring between an SLC 500 and Compact Logix IO. The advantages of using this are a lot less wiring time and effort. So they use pre-engineered cables. It's nice and easy to switch out because it's all tested and ready to go. So you can see here on the video that we've got an SLC 500 chassis. So you start off by removing the terminal box. Once that's done, you remove the chassis itself. You've got the mounting plates. And you'll notice that it uses exactly the same panel holes as the previous SLC chassis, so they all line up perfectly. Always remember to ground your equipment. Once you've done that, each of your I/O cards will have a specific conversion module, and these just snap into the chassis that you've got. Your next stage is to insert all your terminal blocks from the SLC field wiring. You've got a cover plate that goes onto the base plate. This has 2 screws to attach onto the top and then some hinges on the sides. Once that's done, you're ready to mount your CompactLogix 5380 with the relevant I/O on top. And the final step is to attach your conversion module wiring straight onto the front of the CompactLogix 5380.
Okay, the implied benefit in there as well is if everything goes terribly wrong on the day that you're converting, it's nice and easy just to be able to take all that back out again. You've not adjusted the wiring, so you can put the SLC back in again, go and lick your wounds and try it again maybe the weekend after. Ideally, we don't want to be doing that. No. So we've got a number of tools that can help you plan the projects and make sure that that doesn't need to happen. So the first thing we've got is Integrated Architecture Builder, so IAB. This allows you to essentially plan out your conversion, try and take into account all the aspects that are relevant to the conversion as well. So here we've got a screenshot of IAB, and the first thing you'd want to do is open the SLC Migration Wizard. So you've got the button on the top there. Once you've done that, you'll want to add a chassis. At this stage, you can add multiple chassis because some SLC systems might be quite large. In our case, it's just a single rack. We've decided to call it SLC 001 or use the existing name. And once you've done that, you can see this page, which is the module selection window. So on the top left, we've got the option to replace with a CompactLogix 5380, which is the one we're going to be going with. You've got an SLC chassis on the top and a CompactLogix 5380 chassis on the bottom. We've got a L553 processor, so we're going to pop that into the top, and the wizard gives us an option for the number of slots on the existing rack. So in our case, that's 7. The wizard would also prompt you to select a particular CompactLogix processor. We've gone with the 3 meg L330ER, which is also capable of 31 local I/O modules. We've then populated the digital input card, digital output card, and analog in, and you can see all of that on the top, and the appropriate compact I/O cards have been populated at the bottom. Once you're happy with that, click OK, and you'll find yourself in the hardware view of IAB. We've taken the opportunity to also add a little bit of extra remote I/O in the name of Point Max, and we've got an optics panel. You'll notice we've also opted to go for a device level ring topology here. Once you've done that, you've got the button on the top left, which allows you to create a bill of materials. You'll want to check your project at this stage, so you've also got the advanced communication wizards and also any errors or information or warnings that might be present. And then you've got the bill of materials. So here we've got the quantities on the left, then you've got the part numbers and the descriptions, and then the list price. You'll notice that the quantities and the part numbers are exactly as you require for your particular project. Makes it nice and easy. If you send that over to Ratico, your local account manager, we'll be able to quote that with your discounts. On to code conversion. Okay, code conversion. So now you've ordered all the replacement parts for it, we're waiting for them to come, and we've got a little bit of time to look at converting the existing code. So we'll be using the tools that are in Logix 500 version 12. That's the most complete conversion tool that there is. That's going to do approximately 80 to 100% of the automatic code conversion, depending on how the original code has been written. We'll have a look at that in a few seconds. Okay, so we'll be moving that through to Studio 5000 and having a look at the code there. So here's a very simple program that we've used for illustrative purposes. So this is the one in Logix 500. So we'll note we've got a timer in there with a 5-second timer. In terms of the I/O, if we have a look at that, it's just as Jana was saying earlier, we've got an input card, an output card, and an analog. So nice, simple system, just for illustration. Okay, so if we click on File, Save As, save the program as, and normally you'd be using the RSS file, which is the default for saving the SLC file. Now we're going to choose the Logix ACD file, and we're going to export to that, and that's going to trigger the wizard. We'll save that. So the first question, do you want to use compact logics or control logics? Which processor model do you want to use out of those? Okay, and then we can move on to that. So now, how do you want to configure your I/O? So you could, as we said, you can retain the existing SLC I/O, in which case the conversion tool will do that. Or in our case, we're going to replace that, and then we can choose line by line exactly which card we're going to use for that. Okay, not many choices in the terms of the digital cards, but certainly at the moment. But on the analogs, you could have chosen an 8-channel card if you've got a couple more to add into there. Okay, so migrate, and then we can open the Logix Designer tool. So this is coming up as an import now. We've done the export, so here's the import. We're going to leave it as SLC conversion. We're not very original with our file names and object names. And we chose version 34 on there purely because that was on the machine at the time. So here's the import, and then the project tree, pretty much as you'd have seen it in the SLC, except that we've got the I/O shown at the bottom on here. Okay, and then the ladder file here. So the first thing that you'll notice on here is rather than the descriptions, it's got markers on there saying that the conversion tools put your description somewhere else. Why would that be? Well, on SLC, you could either tie descriptions to the address, or you could tie it to a particular instruction using that address. Okay, so there could be conflicting descriptions on there. So rather than putting the wrong ones into there, these are being moved elsewhere, and it's a matter of copying those across as they're needed. So we'll look at the controller tags. Okay, and we'll look here at the legacy values. So this is where all the existing descriptions are. Okay, and you'll see where we had the override on here. The description for the override is actually this one here, enable override. So that one's copying into that tag, and input switch 2 wants copying into the input tag on there. So if we do that and then move back to the ladder, you can see that the first rung looks a lot better now. That's more as you'd want it. So it's just a matter of going back to the controller tags again, copying all the ones across that you need, and then maybe get rid of all these description tags that the conversion tool's been put in, and we end up with something that looks a lot better, a lot happier with this now. It looks something like. So looking through the code, we said it'll do 80 to 100% of the code. So it's got through the first 3 rungs fine. You'll notice that timer on there. I pointed out that it was a 5-second timer. On compact logics or on the Logix engine, we can only count in milliseconds. So it's bright enough to know that we need to change that to 5,000 milliseconds to get our 5-second timer. So that's okay. The next rung down, it's inserted a PCE, or program conversion error. This is a marker label to highlight the fact that we need to do something with the rest of the instructions on this line. In this case, we're using the accumulator and comparing that to a value in the program or in another register. Now that could be coming from a HMI, in which case you can't change it from 5 seconds to 5,000 in the HMI. That'd be a change of procedure for the operators. Okay, or it might be coming from a I don't know, parameterized value or something like that, where it's going to be set and very rarely changed. The conversion program's got no way of knowing that. And so this is part of the reason putting in the PCEs, bringing your attention to it. So we can deal with that now. In this case, this is a system constant, if you like. So we're going to change that, change the preset to 3000 for 3 seconds. Okay, and then we can move on to the PCE, delete that, and we've got no error on the code now. Okay, the next one is on, or the next one to look at is on rung 5. So we've got a system tag in here. So SLC's had a whole host of system tags for doing first scan, for doing maths overflow, all sorts of different things, real-time clocks. In this case, this one is the first pass. So this is a bit that's on just for the first time round, and then it stays off until the program restarts again. Luckily for us, then the system, this system tag has got a new equivalent. So it's S:FS, system first scan. We chose easy ones for this demonstration. So that's the direct equivalent. So that's a nice, easy conversion. If you're using things like the real-time clock registers in SLC, then you'll need to do a bit more work on there. It's not the same process. There isn't a system flag for real-time clock. You have to go and get the values from the processor and then put them into the appropriate registers. Okay, but moving on from here, we can look at the rest of the program. There's a counter in there. It's converted that without any issues, and everything looks fine on there. So that looks a lot more like we'd like to see the code rather than how we first started out. You'll note that I've changed the description background colors to yellow just to keep it in keeping with the standard for Logix 500. I think they come out in grey as standard, but you can always change those. That's just cosmetic. So that was the first conversion. Again, a simple example, but this slide set is part of our standard modernisation workshop, which we've held in various branches and various locations around the UK. We'd like to extend an invitation to you at this point. If this is something that you'd like help with, if you'd like some familiarity with, we can run the workshops and give you hands-on experience doing conversions, handling all the exceptions, and a nice, easy way to bring up questions firsthand and deal with your systems. We can do that at your place of work. It generally takes 5 to 6 hours, something like that, depending on the amount of interaction. But by that time, you'll have been through the iteration process 3, 4, 5 times, and it'll get to the point where you're testing the code that you've converted on a compact Logix and just make sure that everything's working properly. So please get in touch with us if you'd like to do that. We'll happily do those for you.
Thanks, Steve. We've got a number of other further considerations that you'd probably want to make when migrating, because you could just migrate it, but you'd just end up with what you've already got.
Yeah, absolutely. If you always do what you've always done, you'll always get what you've always had. Nothing's going to improve. Okay, so in 30 years, things have moved on a little bit, haven't they? So is there a better way to do what you're doing? So, for example, we've done this conversion and we've still got B3s and N10s and T4s and meaningless addresses, and we've had to rely on those descriptions to make some sense of that program. I don't know how many systems that you've seen that where the maintenance guys have either lost the original files or saved it and not saved the descriptions, and you go to a system and there's no descriptions for any of the code. Well, if you move on to tag names, then the description kind of works in the tag name. You get automatically self-documenting. That might be a better way to approach that. Okay, things like recipe handling. So typically you'd have groups of N registers where you want to put the parameters for recipes and then move them across, etc. On Logix, it's a lot easier to have meaningful recipe names with meaningful ingredients or parameters, if you prefer that, where the variables actually mean something when you first look at the name, rather than trying to figure out what N12 is. So that's another reason for maybe having a look at modernising that part of it. Okay, and while we're on that, I know we've done the conversion, etc. Is this a good time to say, you know what, we're going to just rewrite the code? The original code was written within the strictures of SLC, but we know what the machine wants to do. We know what the process wants to do now. We've got that tied down. We know the mechanics of the program flow. Let's just rewrite it and structure it so it's nice and easy to follow. Worth looking at.
Some of the other things that you'd want to think about, it's an SLC 500. It's probably an ancient machine, so it's probably using a very old panel view that we can't get hold of anymore. Whilst you're modernising the SLC, if you're moving across to a modern panel view solution, so a HMI solution such as the panel view 5000 or the optics panel, it's a good chance to move away from the old address-based tags. So newer HMI tags or logics-based tags will bring in a lot more metadata that you can be using to create and populate alarms automatically, for example. Other things to think about would be older networks. So you could use a bridge or a gateway device, such as those from ProSoft, like Steve mentioned, as a transitory phase. But these networks are going to be more and more difficult to manage and work with as time goes on. Is it a chance to upgrade the entire network while you're doing the system? So can you move your drives and all the other devices that are on that network over to an Ethernet solution, a much more newer, resilient network that you can work with now?
And then we'll move on to analogs. So if you've got a process system, you're going to have lots of analogs. So this wiring system is really useful for not disturbing it. If you're doing machine control, then typically you've got lots of digital inputs and not so many analogs. Is it worth using the analog conversion cables for that if you've only got 5 or 6 wires to swap over? Sometimes it's just easier to rewire those direct. Similarly with the code, you can see on here we've got a scale with parameters instruction taken from the SLC. So we're taking in input 3. It's got an arcane scaling value in here. Every card was a different scaling value. I can remember that it was 3277 to 16384 because it's seared into my memory. But if that's supposed to be representing 0 to 5000 as an engineering value, that's what the scale with parameters was for. On the compact logics, the analog inputs scale the values automatically in the card, so that can come directly out with the engineering values. And so why not use that straight in? Well, if you want to copy that straight into F80, if you want to carry on with the rest of the code, or substitute wherever F8 was used, put in the analog input as it appears as the root value. Or of course you can use aliases. Excuse me. So something else to take into account are some of the speciality cards. So we're looking here at the basic module, servo cards, the stepper motor controllers, maybe some of the interface gateways like the RZ. Yes, the RZ bridge. So these cards don't have a new modern equivalent. It was difficult to use them without referring to the manual on the first time round. It's even more difficult now. It's harder to get hold of the documentation. And as I say, there's no conversion going to be going from that to the other with a program conversion. You're going to have to re-engineer those parts of it. So that's something else to bear in mind.
With the newer controllers, we've got a lot more new capabilities that weren't around 30 years ago. Is that correct?
Yeah, 30.
Yeah. So things like integrated safety. So we've got the ability to have your safety controller look after your entire safety devices rather than having to use relays and a lot of other hardwired connections, particularly going to drives and servo motors and things like that. Integrated motion is another one. I remember going onto site with an SLC 500, some sort of obscure servo module on the front of it. We had a look through the user manual before we went on site, couldn't work it out, but it required an ancient DOS-based program in order to interrogate it. If the site had backed up their SLC, and a lot of sites don't, unfortunately, even with an SLC file backup, the data or the configuration information in that server module won't be available to us. So we couldn't really do much with that. One of the advantages with integrated motion is that everything is programmed within Studio 5000. So when you back up your ACD file, that includes your entire motion setup. Premier integration and drives, network switches, and all the other stuff Rockwell sells. This provides us with add-on profiles. So getting the data, mapping it all out, that all becomes a breeze because the add-on profiles are already in the Studio 5000 yeah. With Rockwell's object libraries, that's another fairly good development where you can have faceplates all engineered with all the engineering code behind it, maintained by Rockwell, and also with user manuals provided for it. So instead of you having to sit there and try and engineer all these, you've got faceplates that you can just drag and drop into your various HMI or SCADA systems.
Okay, so one of the other new capabilities is automatic device diagnostics. Now, the 5380 and the Control Logix L8 processors have this facility built into them that's not been available before. So this is the ability to have a look at the system that it's connected to, look for faults and errors, and then push those faults out to an alarm page or the diagnostics page rather. So all you need to do is to provide that page on the HMI or on your SCADA, and the processor will push all those information messages out on there. So we can take a couple of examples on here. The first one on this particular list is connection lost with device, and that's the Ethernet card. Okay, the next ones are no load detection on one of the diagnostic input cards. So writing code for that to come up to help maintenance was very, very labor intensive before. This all comes with no code, so no need to spend time setting it up. Provide the page as a receptacle for these messages to drop in there, and you'll get them automatically.
We've got a massive host of modernisation resources. So we've got reference manuals, application profiles, user manuals if you really want to read through all of them. We've got IAB, which we mentioned earlier, which is a very useful tool. It's free to download, free to use. You've got knowledge base available from Rockwell as well. And then you've also got animations like we showed earlier and a video. Video is quite handy because it gives you the entire process that takes about 10 minutes and cuts it down to about 3 minutes. So you can see exactly what you're getting yourself into.
Okay, so that's the end of the presentation side of it. So thanks for your attention. We're going to move on to questions and answers now. We've got a team in the background who have been handling those, as we said. So let's have a look. So IAB, oh, sorry, is IAB a free download from the Allen-Bradley website? Or how can we get a copy of IAB, sorry? Okay, so yeah, it's a free download. The link to to get IAB will be included in this presentation, which will send you a copy with all the links that Jana said. So yeah, you'll get that. Really useful tool.
Next one we've got is, what is the route to change a system with large remote I/O on DeviceNet and has a basic module on I/O? I'll leave that one to you.
Okay. Yeah. Thanks, Janet. Okay, so remote I/O, we'd look to transition that to I/O sat on Ethernet. So if you're using typically on remote I/O back in the day, it would be Flex I/O sat on there. So fairly easy if you want to just change the the Rio adapter on the Flex I/O, swap that out for an Ethernet, and that can be connected up on Ethernet, and we're off. If you got some reasons why you can't do that, or you maybe, I don't know, maybe you can't get the wiring going out to there quite yet, then there are options from, or the ProSoft ANX card can act as an interface between there to maintain the Rio side and yet connect the Flex IO on Ethernet. Okay, so what was the second part of the question? It's got a basic module on the IO. Okay, so the basic module was a secondary processing module, typically taking things like barcode information from serial ports or maybe running a printer or something like that, just doing some secondary computation and then passing values back into the SLC, or maybe doing as I say, a tally printer or something like that. Pretty much that needs re-engineering and using some new methods. So maybe you can do that using the serial card on the compact logics and drive the printer straight from there, or use one of the compute modules, or maybe even the optics gateway now, which can do a lot of processing on there, taking the values straight out of the SLC or out of the serial port and processing those and passing those on. Okay, so are we got any more questions on there?
We've got that other one, which is the...
Okay, so what size processor would you recommend for a single rack of IO, of SLC IO? So Rockwell are pretty good at guesstimating the size of memory versus the IO. So the 0.6 or the 600K version and the 1 meg version will both do 8 slots locally as the IO. The next ones up will do 16 slots, and then the larger ones, the L330, etc., will do 31 slots. So if you've only got a few, like the example that we used in the in our demo, the L330 was well over spec for that. I think an L306 would be easily enough for doing what we were doing there, unless there was anything special that you were looking at.
If you're looking at object libraries, you'd want to get a larger processor, and L310 would be ideal if you're looking at doing things like that, because the 600 kilobytes could be a bit restrictive.
Yeah, sure.
We have some new messages. So we've got, does the conversion now group bills when using a word, say, is that N?
Oh, yes. Okay, so yes, I know where we're at now. Okay, so when we were mapping IOs on SLC, you could use an integer and use all the bits in an integer to drive the outputs direct, or maybe you'd map the inputs into an N10 register as well to get all the bits. It doesn't do it natively or as standard because the data structure is different in the input and output cards, but you can use it. You can change the mode when you first introduce the IO card and make it to follow that pattern. Otherwise, there's a couple of add-on instructions which they'll do the same thing, and you can adapt that. And if you don't want to do that, then you can, for every card, you can just introduce 16 lines of code and do the mapping at the bit level individually. A lot neater in the add-on instruction though.
Got Darren furiously typing away. How do you handle 32-way digital input cards when migrating to compact logics? I can do that one. It's a modern processor, so I've got the answer to this. So as it stands, compact logics 5380, the maximum density IO cards you can get is 16 channels if you're on digital IO, 8 if you're on analog. We have got high density cards coming on the way, so it is something that's being worked on. We don't have an ETA just yet, but that is in the process. For the time being, if you're moving from 32 channel to 32 channel and you want to keep it constant, you might want to look at control logics where it's appropriate. If your application is fairly small, then you'd be looking at 2 16 channel cards instead.
Yeah, the other thing to think about is if you've got a whole rack of 32-bit cards and it's moving it to 2 lots of 16 for each channel, then you're going to run out of space on there.
Yeah.
So yeah, after that point, you can bring some of those back down to another rack that sat on the end of an Ethernet adapter, and then start again with those. Put in I/O from local to remote on 5380 is going to have no effect on the control time or the you know, it's not going to be dependent on bandwidth like some of the old networks were. So that's nice and easy to do.
Darren is no longer furiously typing away, so I think I think we're all good.
Yeah. So if you've got any further questions, or you've got specific questions on your particular circumstances, please do get in touch with us. We've got the general contact details on there. Okay. Or if you're already talking to your local branch, your account manager, or indeed one of our PSS team, then get in touch with us and have a word with us about your application. We'd love to help.
I think it's important to note that it's not just the two of us that are here to support you. We do have a wider team of automation software specialists, 8 of us in total at the moment. So yeah, just get in contact and we can give you a hand. Ah, Darren. Right, one last question. Can the CPU rack be changed at and work with existing Rio racks initially, then change the Rio racks out later? That would be with
Yes, it can using the... I don't know. We'll have to come back to you later on that one. Yes, if it was flex, but if it's SLC remote I/O, then you might need to change the adapter. I think that'd be the way to go. But again, we'd recommend taking the SLC stuff out now anyway. It's going to be difficult to find spares. Okay, so yeah, thanks once again for your questions. Thanks for your participation. We'll look forward to talking to you with your specifics, and we'll see you at the next webinar. Thank you.